All right, so what have we done so far? We have understood the terms of radicals. You got a radical sign, you've got an index, you got a radicand. We learned how to change form from radical form to exponent form. So for example, class, what is 49 to the 1/2 power? 49 to the 1/2 power. 7. So remember, changing radical form to exponent form to radical form, anything to the half power is the exact same thing as a square root. It's the same as the square root of 49. The 49 to the first, the index is 2. All right, we did that. We also learned how to simplify radicals. Taking a square root, you got to find 2 of the same factor, and the root is whatever that factor is. Doing a cube root, you need 3 of the same thing, and the root, cube root is whatever that factor is. 4th root, 4 of them, 5th root, 5 of them. All right, now we got to start doing operations. We got to operate on our radicals. Now we're really getting radical. Let's do some operations. And the first one we're going to do is multiplication. It's pretty simplistic. If you're going to multiply 2 radicals, now I will say this, technically, you can only multiply a square root times a square root, and a cube root times a cube root, and a 4th root times a 4th root, technically. So, the nth root of a times the nth root of b will always give you the nth root, meaning square root times square root is a square root, cube root times cube root is a cube root, 4th root times 4th root is a 4th root, etc., etc., etc. And what would you expect to do with the radicands if you're multiplying? You'd multiply the radicands. So you end up with a times b as now your new radicand. Nth root of a times the nth root of b is the nth root of a times b. That's pretty simplistic. That's all there is to it. 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 All right. So if you get to a simplistic problem like the square root of 3 times the square root of 7, guess what? It's the square root of... Gee, that was hard. Square root of 21. And you get the square root of 5 times the square root of 11, and that's the square root of 55. That was hard. All right, so look. I know math is hard, and we didn't cover what to do when you have 3 things multiplied, but what would you get? And just go ahead and write it in on your paper. What do you get if you multiply the square root of 2 times the square root of 3 times the square root of 5? I know this is impossible because math isn't orderly and it doesn't follow things, and we have no idea what to write. But maybe the answer is square root of 30, right? Because math makes sense. All right, let's add something a little bit over here, and we'll just put a little note. Note, the square root of 2 times the cube root of 3 equals the square. Why do I have a 2 for the index? All right, stop that. Equals the square root of 2 times the cube root of 3. You can't do anything with it. Okay? The square root of 2 times the cube root of 3 equals the square root of 2 times the cube root of 3. Unless you're extremely, 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 extremely creative. Now again, for our purposes, we're going to leave it square root of 2 times cube root of 3. It's not the 5th root of 6, okay? It's not. So don't be doing that. You can't do that. I mean, the only thing you could even, if you were creative, want to try to do is, and don't write this, it's just confuse you. How about if I said 2 to the 1/2 times 3 to the 1/3? The only problem is, we can't do anything there either because the bases aren't the same. So it's still 2 to the 1/2 times 3 to the 1/3. So we could change the form, but it really doesn't get us anywhere. So just pay attention, square root times square root of square root, cube root times cube root is cube root, etc., etc. And away we go. Now, that's real easy. So you're going to say this section is going to be really, 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 really easy. Well, except students are going to mess up on this second part. When multiplying, you should always look to see if you can simplify. And this is where students are going to mess up on these easy problems. So when we're doing fractions, we ARB them, reduce before we multiply. When we're multiplying radicals, we SB them. We got to simplify before we multiply. All right. So if we were technical, let's do the first one technically. If we were to take the rule, our radicand would be the 6 in red times the 3 in green. Do you agree? If I'm going to do the rule. Now, I don't want to say 18. I don't want to write an 18 there. You know why I don't want to write 18? Because if I'm going to simplify the 18, what do I have to do? Factor it. Into what? Like 6 times 3? Gee, that was a waste of time. I just made the 6 times 3 and 18. Now I got to make it back into a 6 times 3. That's stupid. I just wasted my time. So I'm just going to leave them. Let's go ahead and factor the 6 into a 2 times 3. And do you now see that this one simplifies? We're doing a square root. How many of the same factor do we need? 2. Do we have 2 of the same thing? We do. We have 2 3s. And the square root of 3 times 3 is 3. And what do we have left? A square root of 2. So we get 3 times the square root of 2. Is everybody okay with that? I dare say I could give you that exact question on a quiz. And unfortunately, numbers of you aren't going to write 3 times the square root of 2. You're going to write square root of 18. Don't let that be you. It's like always, we've got to look to simplify. And so you want to simplify before you multiply. Now, the best way to simplify and multiply, don't write this in your notes, is just skip this step completely. Don't even worry about that. You know they're all going to end up being under the same thing. Just do your simplifying right here. So let's do it this way. We'll take our red and we'll make a big box because we need room under it. And let's S-bum right here. Just do it before you multiply the 2 together. So if I'm going to do this, I'm going to look to factor. So I'm going to take my red, I'm going to change the 25 into a 5 times 5. And I'm going to cross out my 25, right? Because it's now a 5 times 5. And I'm going to keep my red. I'm going to go over to this 10, and I'm going to change it to a 2 times 5. Agreed? Can we take the cube root of anything with the numbers? Yeah, we got 3 5s, don't we? So with our 3 5s, we can get a 5 out, right? And I got a 5 out. And should I even bother to factor my x's? I mean, you can if you want, but I'm not going to. I'm just going to circle them right now. And by the way, if this were my homework, I wouldn't be circling things because it gets too messy. But I would be crossing them out. But you can circle them if you want. But isn't x squared times x, x cubed? Or isn't it x times x times x? Yes. Do I have enough x's to take the cube root? Earth to people, you got to be thinking, right? Right? I need 3, don't I have 3? So the cube root of x cubed is x. And what's left in there? What do I got left? A 2? That's it. 5x times the cube root of 2. That's the multiplication of them. Now don't write the cube root of 250x cubed and then go ahead and waste your time to unmultiply it all and simplify it. You simplify it before you multiply it. And if you do it even before putting them under one radical, fine, because they're all going to end up under the same radical anyhow, so just simplify them right there. What if you had 3 of them together? Okay, now I have more things available to get the right amount to take the root. I need 2 to take a square root, 3 to take a cube root, 4 to take a 4th root, etc., 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 etc. All right. Uh-oh. Oh, well. Whatever. Let's roll on. All right, so again, this is just simply what we did. You can simplify before putting it under one radical. So what I want you to do is I want you to do A and B, see what you get. Go ahead and do A, go ahead and do B, and see what you get. All right, so did you say 14 is a 2 times 7, and a 21 is a 3 times 7, and hey, I got 2 7s. And the square root of 2 7s is a 7, and everything else is left in, and that's a 6. 7 times square root of 6. How many got that on the first one? Awesome. You guys are great. And you look at the second one, and you say, hey, 12 is a 4 times 3. And are you at the point where now you're just taking the square root of 4, and it's a 2? I mean, you can make it a 2 times 2 if you want, knock yourself out. 30, 3 times 10. You know what? A 10 is going to be a 2 and a 5. Do I have any other 2s? No. Do I have any other 5s? No. I'm not going to waste my time. 3 times 3 is a 3. And I'm left with the square root of 10. So how about 6 times the square root of 10? How many got that right? Awesome. And those aren't hard, right? As long as you remember to simplify before you multiply. Any questions on those two? Can I help you understand anything on those two? Okay. Let's roll through the next two then. Go ahead and do those next two. Variables. Dun, 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 dun. Dun, 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 dun. You can do them. Just take them one step at a time. Hey, why don't you do D before you do C? Because you'll feel better about D. It's easier. And then do C last. All right. Let's see how you did. You can keep working a minute or two if you're not quite done yet. That's really the only thing you're going to get there is a 3 out of this, right? And that's all I'm seeing. If I can get 1 3 out, and the rest is just multiplied, put numbers in the front. So that's a 10. And usually put your variables in alphabetical order, so A, N, P. 3 times the square root of 10 A, N, P, minor deduction if you didn't put it in order, but that would be the proper way, the best way to leave your final answer. So without worrying about the order, how many got 3 times the square root of 10 ANP? Okay. So again, you're just looking for 2 of something, right? And there were only 2 3s. That's it. That's all we had to deal with. Nothing else is there. Now on C, though, you're always checking the index, right? Your index gives you your orders. You got to know what the index is. The index tells you what to do. It's a cube root. Looking for 3. All right, I'm going to leave the red one alone, and I'm going to get to this black one. I'm going to make a 20 of 4 times 5. Now, I would stop and do the 2 and the 4, but you might keep going and make the 4 2 times 2. And I already see I have 3 2s. I'm getting a 2 out because of those 3 2s. And I have A's and B's and X's and Y's. What in the world was I thinking? Your paper's better? Did I change them all to what? X and Y? Okay, good. Because I thought, what in the world? All right, it's supposed to be X. It's supposed to be Y. Much better. Okay, so I have already 2 X's from the left, so why don't I make this one X times X? And now I can pair up 3 of them and take the cube root of those 3 X's and get an X out. And guess what? I have 3 Y's. So that Y, one of them, and those 2 more, and I can take the cube root of that and get a Y out. And what do I have left? Don't forget your index. I have the cube root of 5X. How many got that correct? Look at that. And if you missed it, do you know why? You see what got you? Was it a little thing? Okay, just take care of those little things. Any questions on those two? Anybody? Questions? Peoples? All right, let's kick it up to the next level. Let's kick it up to the next level. What if we have coefficients? And the crowd roars. Not a big deal, right? Coefficient and multiplier of the radical. So who wants to do this rule? Somebody raise your hand and tell me the rule. Tell me what to write. Come on, you can all do it. No guts, no glory. Andrew. A times B. I agree. That's good. Yep. Okay, and real close, I would have said times, and I would have said the nth root, right? Because it'd be a square root, cube root, fourth root, right? But yeah, he's got the concept. Multiply the coefficients, multiply the radicands, right? That's all you're doing. Multiply the coefficients, multiply the radicands. Oh, looks like another rule for the rules section of your test. You guys need to start, I mean, you should get 100% on those rules. And I'm telling you, it's those rules that are key. And as I look more and more at the SAT, ACT, I see more and more of the rules coming into play with stuff. You have them on every test, every test. Stop missing the same one over and over again. Take the time to figure out the rule you miss all the time and get it right. Okay, so that's the rule, so pretty simplistic. But remember, you don't want to be a bum. Make sure you S-bum or you R1. So you got to S-bum. All right. So again, I know I'm going to be multiplying, but before I multiply that negative 2 and 4, let's see if anything comes out. Well, do you already see the 2 that the 6 has and the 2 that the 10 has? So I'm getting a 2 out, aren't I? You could put it anywhere you want. What would the 2 do to the negative 2 and the negative 4? Okay? It would multiply, right? So I can stick it wherever I want to, but I just got to make sure I keep everything clear. Now that's it, right? Nothing else is coming out. So let's multiply our now coefficients. Negative 2 times 2 is a negative 4. Negative 4 times 4 is a negative 16. Do you agree? We got a negative 16 out front. And you could have done negative 2 times 4 and got negative 8 and multiplied that times 2. And you still get negative 16. And what do we have left in? We have a 3 times 5. You're going to multiply those, right? And get to 15. And we have a y. So negative 16 times the square root of 15. Wow. Not too hard? All right, why don't you guys try the next one? So why don't you try this next one? Kind of interesting. It's already got a 5, then a raised dot, then a 3. Cube root of 2x, raised dot, cube root of 5x. See what you can do with that. This one shouldn't take you long. Done yet? Who wants to give it to me? Somebody raise your hand and give it to me. Adam, give it to me.
15x times cube root of 10x.
Okay, does yours read the way mine reads? Just want to make sure.
Our second x is squared.
Okay, I thought so. Man, those are 2 changes I made, and I didn't make them to my notes. Okay, so now I agree with Adam. Adam did see that he could get an x out. Comes out as a multiplier. And so you get 15x, and what is left in? The cube root of what, 10? Very good, right? How many got that correct? Sweet. Nice. All right, good. Let's kick it up a level. Whoa, I changed colors. It's amazing. Uh-oh. Dun, 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 dun. Dun, 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 dun. All right, what comes to mind when you look at D? What one word pops into your mind? Beautiful. Right? Distribute. Distributive property. All right, so what do we have? Remember, what's the can somebody tell me the full name of the distributive property? It's really the distributive property of multiplication over addition. But be careful, right? There's 2 parts to it. All right, so I'm going to do this one up here. You do it at your seat at the same time. Look if you need to. If you don't need to look, don't look. All right? So go ahead and distribute that and see where you end up. How'd you do? Did you catch the simplification on the second one? Now, normally, I would have just written the second one as -6 right off the bat, but I wanted to be clear for your guys' sake, because I would have seen square root of 2 times square root of 2 is a 2, and I would have written right off the bat square root of -6. How many got that correct? So talk to me. What got you on this? Talk to me. Andrew?
So why is the -6, and why is it not multiplied together?
Okay, so great question. That's why I asked. All right, so let's just go back to basics. Let's suppose we had a 3 times a 2x minus 5. So I would take this 3 and I would multiply it times the 2x, and I would get a 6x, and then I would take this 3 and multiply it times the -5 and get a -15. And I would get two things because I'm distributing. So the first time I took this and multiplied it times this, and that was 15 times the square root of 14. The second time I took that and multiplied it times that, and that was the -3 times the square root of 2 times 2, which simplified into this -6. And again, notice, one term, two terms, one term, two terms. Once in a blue moon, those two things will add up, but usually they do not. Usually you can't add those two things up because they're not like they're. Did that answer your question, Andrew? That was a good question. What else? Who else? Tell me what's getting you. What's getting you? Anybody else? Kirsten?
So when I did it, I got your answer after you distributed. After you did it, I got that, but then simplifying it, I guess, got me.
So did you leave it -3 times the square root of 4 on the back?
Yes.
And what is the square root of 4?
2.
Why'd you leave it square root of 4? Just like, why would you leave something with like 10 over 2? You divide the 2 into 10 and get a 5. So you did everything right, you just had to finish it by simplifying it. Okay? Other questions? Anybody else? Lauren?
For the square root of 14, do you not simplify because it's just 2 times 7?
Yeah, and see, you don't have enough to get anything out. A 2 and a 7, can't get anything out, so I'm going to leave that one. And I looked at it in the beginning. Great question. Anybody else? Any other questions? Okay, so now let's step it up to the next level. All right, same one. Similar. Let's do this one fast so I can get to that last one is really where I want to go. All right. So let me talk you through this one. When I'm looking at this first one, I already see that there's going to be 2 3s. Do you see that? You may not. My advice to students is, for this step, just leave it like that and then do your simplifying. It'll be clearer for you. I'll come back to that in a minute. Now let me do the second distribution. And do you agree that's a positive 14 times the square root of 3 on the back? Everybody all right with that back distribution? So really all we need to do to finish is simplify that front one. And again, now I'm going to factor that 6 into 2 times 3. And now I'm going to take that square root of a 3 times 3 and get a 3 out. All right, so I factored the 6 into 2 times 3. I was able to take the square root of the 2 3's. So my final answer, 6 times the square root of 2 plus 14 times the square root of 3. Do you agree? 6 times the square root of 2. Now questions. Raquel. Okay, which part don't you get? Okay, so, all right, so watch, Raquel. So now let me just work with you. Okay, first thing we're going to do, 2 times the square root of 3 times the square root of 6. What do you think I should write for that? 2 times square root of 18. Okay. You want to multiply them already, Raquel. I don't want to multiply them because I'm going to have to unmultiply it. So you're not S-bumming, but you are thinking correctly in how to multiply two things. The only thing is you're making it a little harder on yourself, but I'll leave it that way. Okay? Now do the second distribution. What do you get when you multiply 2 times the square root of 3 times a positive 7? Okay, and it's a positive, right? 14 times the square root of 3, right? Isn't that plus sign there, right? 2 times 7 is a positive 14. Got to keep that plus sign there. Now simplify your square root of 18. Oh, I have to unmultiply it back to a 3 times 6. And I have to make the 6 a 2 times 3. And now I'm ready to get a 3 out. And guess where we end up? 6 times the square root of 2 plus 14 times the square root of 3. But again, you'll save yourself a step if you don't multiply these, seeing that you're going to have a common 3. There's 1 or 2 of you in here, you can simplify it right on the multiplication. You see the numbers clear enough. You see that you're going to get a 3 out, and you could right away write 6 times the square root of 2 because your brain works that way. There's only a few of you in here where that's the wise way to go. The rest of you, you try that. Some of you try that, you're going to make a mistake, so just be careful. It's not worth it on a quiz or test to make that mistake. But a few of you can do that. So now we have a similar situation, right? Same scenario, yes? Distributing. All right, so on this one, I want somebody to raise your hand. Everybody should be thinking what it is. Somebody tell me what to write on the front distribution. John?
Negative 2 times the square root of 6 times 5.
Okay. And that's great. I would go all the way to 30 right now, but 6 times 5 is fine, John. But I already know a 6 is a 2 and a 3, and a 5 is a 5. Are we going to be simplifying that? No, but it's okay to write 6 times 5 and get it on the next step. That's not a problem one bit. But look, I'll tell you this. This is the key. While you're looking at distributing, think about the factors if there's going to be anything to simplify. Because that you got to have that in the front of your mind. Okay, but that's good. That works. 6 times 5 or 30. We'll get there either way. Somebody tell me what to write on the back. What to write on the back. All right, looking for somebody new. Come on, participate. Ashton, tell me what to write on the back.
8 times the square root of 60.
So just like this. Okay, we're closer. The sign has to be there, Ashton, but is it a negative? Let me add a 1 there. Now what would it be? What's a negative 1 times a negative 8? But okay, but if I just leave 8 with no sign, that's multiplication. You've got to have that plus sign. Okay, everything we distributed, that when it's a plus, that plus has to be there. Now, did you look at the fact, Ashton, that a 6 and a 10 will have a common factor? Did you think about that? That's what you got to be thinking. Otherwise, you just wasted your time in making that a 60. Because guess what your first step is going to be? To go right back to a 6 times 10. That's going to be your first step. Because you're going to be able to simplify that. Okay? So, I would have left it 6 times 10. Our front, negative 2 times square root of 30. But look on the back. Here, let me do this in red. 2 and a 3 for the 6. 2 and the 5 for the 10. See the common 2? We got 2 2's, right? We can take the square root of those 2 2's. We get a 2 out. Now what's the back? Plus 16 times the square root of 15. And that's the simplified answer. You always got to be looking to simplify. You always got to. So here's the key. And I just discovered that with you guys. You know, all these years of teaching this, I never thought to tell a student, because it's something I just do naturally. While you're getting ready to do the multiplication, think about the factors and think about if it's something that simplifies. If it's going to be, then leave it in factored form. Hence, the back one we left as a 6 times 10. But if it's something that doesn't have something that you're going to be able to simplify, take the root of, then multiply it out. Hence, the front one was a 30. Do you understand that? Kirsten.
Why can't you simplify from both of them? Like,
What do you mean? Like do something more?
Yeah.
What more do you want to do?
I mean, for me, I'm just asking why. For me, I did 30 was 3 times. It was the 6 times 5, and I did 2 times the 3. So I can simplify both of them out of each under each bracket.
Okay, but the square root of 30 doesn't simplify.
I can ask you. I have to show you.
Okay, show it to me. Show it to me. All right, I think you guys have one more on your paper, right?
Yep.
Okay, so I think it looks like this. You have a 2 times the square root of 2 minus the square root of 6, and that whole thing is squared. All right, now, we're not going to make the common mistake, right? Because we've already talked about how to multiply in that situation. So what would be the first thing you would do on this? Josh? 2 parentheses, right? Josh says this is 2 times the square root of 2 minus the square root of 6 times 2 times the square root of 2 minus the square root of 6, right? And now we're multiplying 2 whats? It's not a difference, 2 squares. What kind of polynomials are each of these? They're each a binomial. So we're multiplying 2 binomials. So what are we doing? We're distributing, right? I got to take the front and multiply it times the front, right? Let me go higher for you guys. So 2 times 2 is 4. And for your sake, I'm going to leave it square root of 2 times 2. Because I know I'm going to take the square root of that. Now, I would have written 8 right off the bat. But again, some of you don't see that so clearly. And that'll end up in 8, right? It's going to end up there. Let's do the second distribution. A positive 2 times a negative 1 is a negative 2. And I have the square root of a 2 times 6. Do you see how we're going to get a 2 out of that? Aren't we? If you got a 2 and a 6, aren't we going to get a 2 out? That's why I left it as 2 times 6 instead of 12. Because I already see the 2 from the 6. I know I'm getting a 2 out. Now let's do the other distribution in blue. What's a negative 1 times a positive 2? A negative 2 and a square root of 6 times 2. So you got a negative 2 times the square root of 6 times 2. And now do the last distribution. Negative times a negative is a positive. You got to have that positive sign there. And we have a square root of 6 times 6. And now all we got to do is simplify all these radicals. All right, you do it as I do it because our time is running out here. If I could read my writing, I'd be in good shape here. All right, everybody pause for a second and look. So you should be at this point. Should have gotten an 8, a negative 4 times the square root of 3, another negative 4 times the square root of 3, and a positive 6. Can we finish by adding like terms? Absolutely. Add the 8 and the 6 and get 14. 4 negatives of them and 4 more negatives of them is negative 8 of them. 14 minus 8 times the square root of 3. That's where you should end up. Some of you, if you're wondering on that, go back and watch the end of the video. It'll be there for you. All right, homework's at the bottom.